Hello, everyone. How are you going? Good morning, good evening, good night. So today we're gonna talk about security and vulnerabilities and audit smart contracts. Obviously in Solidity and for public and private smart contracts. So will be an exciting and theoretical topic that we're gonna talk today, and also we're gonna just experiment and we can try to deploy and test some smart contracts just to test the vulnerability. So before I start, I'm not alone. I'm with Calvin and Robert as usual. So you have the word, Robert.
Thank you, Rafa. If you're looking at the screen right now, we've had two previous streams about security, both hosted by Davi, 101 and 102. Definitely worth a watch if you're building your own applications using AI. And I'm looking forward to this one today. And of course, already the announcement as well that we'll have another stream coming in 2 days on real world assets, also hosted by Rafa. And we'll have a stream on Friday the 8th about ideating with AI, with among them also Calvin, which will be experimenting AI to build new ideas. That was my announcement. I'll give it to you, Calvin.
All right, yeah, look forward to that one. We'll be sharing some personal stories as well for ideation stages of well startups and yeah, but for this, look forward to the look forward to what you're going to show us, Rafa, which is security, which is very important as we learned in 101 and 102. 102. I think
Right,
Kid is
Calvin.
also here.
Kitty is also here. Yeah. Okay,
Oh,
so let's start. I created a repo in my GitHub, obviously my GitHub profile. So I will explain a little bit of this repository. This is a boilerplate. A boilerplate is basically a repo where it has the basics, what has the basics of the setup of the project. In this case, I'm using the tool called as Foundry. So Foundry, all right, we're gonna look for about Foundry with three. So
You
Foundry is
recently had
that
a
tool.
stream about
Yeah,
Foundry, actually, for those who've missed it. Yeah. Sorry, Rafa,
yeah.
go ahead.
No, yeah, yeah. It's okay. It's
Yeah.
okay. Um, so Foundry is basically this tool just to experiment and to write, deploy, test, whatever you want to do with smart contracts in Solidity. Is a really cool tool because you deploy and test with Solidity. In the case of Hard Hat, you deploy with TypeScript and or with JavaScript and whatever. So it's basically that the setup of this repository, and also has the configuration to add your private key of Cody for test and maintenance, absolutely, and also the RPC. All right, so the RPC you can get it just going to the documentation, and that's it. So easy. But if you click here, I will publish this link. You can go just you will copy this link and that's it. I will share it in the chat. Just 1 second. I will share it right here. Okay. So once I share it, um, and if we go to the branch called as Feed Kira, I actually upload some smart contracts and some documentation about the vulnerabilities that's the topic we're gonna talk today, and also some commits you will see in that branch. All right. So if we go to that branch, we will find some commits I pushed, um, that I already pushed. But let's see the changes and let's see the things I want to show you. So I created a wiki where you can go and I explain all the topics you can check because it's very important just to understand the basics And once you understand the basics, you can understand what kind of vulnerabilities exist in Solidity when you are trying to deploy something or when you are trying to execute a function. It's very common in obviously in this ecosystem in Web3 that the hackers know the smart contract code so they can study and they can access to a function that has a vulnerability or has something bad or that is not private and is public and that is available for everyone. So that's the thing we're gonna see. And also explain a little bit of the ciphertext because the ciphertext is that object in Cody blockchain that encode and has the encryption also for like let's say like for an address or for an amount or for a string that is a text and whatever. So this is how the ciphertext looks. As you can see, the first one says literally ciphertext that you will get like an encode string in hexadecimal. Why hexadecimal? Why hexadecimal? Because it starts with 0 and X. Also has the R, has encryption key type, and the data type. So you should understand how it looks and how is structured this object. Um, just because we're gonna check it for the next topic. So if we go for the basic, I also created this page that we will find the top 15 most common security vulnerabilities in Solidity smart contracts. So this is for public smart contracts. All right. So these vulnerabilities are available, or you can find it in public smart contracts like in Ethereum or like Polkadot EVM or any blockchain that accepts EVM. So this is the basics. You will understand like the top 15 like are super basics, but you need to understand because this is a best good practice if you solve and if you can solve and understand these issues. So all right,
Can
yeah,
I ask you a question? So this is a
of
very
course.
basic question. Why would why deploy a public smart contract when you can deploy a private smart contract?
Good question, Colvin. So basically, a public smart contract are literally like only available in public blockchains like Ethereum.
Okay, all
Um,
right. So
mhm.
it's just a vulnerability that Ethereum has, being a layer one blockchain, right?
Yeah, yeah, in layer one, and also you can deploy in layer two. But sometimes, like for example, in layer two chains like Arbitrum or uh, any other zero knowledge layer two blockchain, um, you can also try to make a private smart contract, but it's not full private smart contract because only has like the some variables. All right. In the case of Cody, you have a lot and a bunch of types and structs that are private. So this is literally a full private smart contract that you can build in Cody um, instead of Arbitrum smart contract. So
Okay, all right.
yeah. Uh, so let's start with reentrancy. What is reentrancy? Uh, I have or actually you can see like this function that is a vulnerable code. So what I'm doing here is a function to withdraw the funds. As you can see, this is a basic function that accepts only an amount that is public and also has a requirement. The requirement says that if the balance of the message sender means the user that is calling this function. So the requirement is that the balance of the message sender or the user is larger or equal to the amount that is into the parameter, you can access to the logic of the function. That is this logic. Okay, so here we have also a requirement to make the transaction, and then we update the balance of the user. What happens here? The thing here is that if I want to call this function because it's public, and public means that smart contract and users can call this function, I can access to this function and just withdraw all the funds before updates the balances of my wallet. All right, so this is really vulnerable code, and was famous to use this code like in 2019 and 2018 because if I don't remember, the compiler version of Solidity was like the 05.0, and today we are like in 09 version of compiler. So the thing how to you can solve this vulnerability is just updating the balance of the user before make the withdraw. All right, because if we update after the withdraw, we can start right here and make a loop. That loop means that I will call this function and call and again and again and again before update my balances. So we can check it, and you can check it just testing it like in any chain you want. But I would clone. I already cloned my repository, and you can open the repository just changing to this branch that is feed/Kira, and let's check the contract how it looks. Right. So I added also some comments, like a title, like what is vulnerable, like everything is explained right here, so you can just read and you can study this smart contract. So basically, I will explain how it looks. So we make
Could you
the function.
perhaps zoom in a little bit for the viewer?
Oh yeah,
If I
of
may
course.
ask. Yeah.
Yeah,
And,
that looks
the same
better.
for the other page with the repository, if possible.
Oh yeah, got it. Okay.
Yeah. Thank you.
Yeah. So I made this function just to deposit, and I add this feature that is payable. What means payable? Means that you can send the native cryptocurrency from the chain where the smart contract is deployed. In this case, for example, is Ethereum. So this let the function and let the user send the cryptocurrency to this smart contract. Okay, so there is not much to see. You can deposit and also you can withdraw. Right here is where I explain where the attacker or where the hacker can call the withdraw function before the balance will update. Okay, so I can like call this function like 100 times, and I can withdraw all the funds from this smart contract before my balances has been updated. So that's how return vulnerable works. But the thing I want to say is that just to avoid these kind of vulnerabilities, okay, you should use obviously OpenZeppelin. Why OpenZeppelin and what is OpenZeppelin? So basically, OpenZeppelin is that tool to inherit another smart contracts and professional smart contracts and safe smart contracts made by OpenZeppelin team. So they provide you like a standard of the contract you want to make. You need to inherit, and you can modify some functions. That's it. So the thing with OpenZeppelin is just to save your smart contract that you want to deploy for your project. If we explore a little bit of OpenZeppelin, we can find some examples that OpenZeppelin can make for us. And as you can see, is importing the library of OpenZeppelin. They have like a library for ERC20, for ERC721, Living 55, for stable coins, for real world asset, and for any other kind of smart contracts you want to make. Obviously, the most famous. So how do you import OpenZeppelin to your smart contract? So I'm in Kiro, and I will create like a simple smart contract right here, and I will call my my RAF token. Okay.
For those who haven't seen it before, could you highlight what is Kiro?
Oh yeah, Kira is basically if you saw the last live stream I made was about Kira ID. So Kira ID is basically an editor for code, but with power. All right, with AI. The only AI is available here is Cloud Sonnet, Cloud versions 3.7 and 4.0. But Kiro has a lot of features. As you can see, I can add some hooks on the steering. I can connect to an MCP server, and that's it. It's like a cursor, but to be honest, I like more Kiro than cursor, because
Oh, really?
um,
Wow.
yeah, it's split more like why? Because Kiro has the prompt engineering in UI. In Cursor, you do not have it. You just need to learn about prompt engineering to insert in the agent of Cursor. So that's why I'm using Kiro today. Um, so that's it. I will create a smart controller right here. I will just try to add the Pragma Solidity. If you know, only Kodi accept this version. This version is called as Paris version of compiler. And this is the maximum version of the compiler that Kodi application accepts. All right. So I'm gonna make like my RAF token. And that's it. I will also install Open Zeppelin right here. This is a very good practice. You should always use Open Zeppelin for all your smart contracts, okay? Because if you do not do that, the community will attack you and will cancel you. But it's usual because the community knows about Open Zeppelin and also about the good practices of a smart contract because they know about their funds and about what they are investing. So let me go into the documentation of Open Zeppelin, and I will install the library. Okay, let me go to Open Zeppelin docs. Contracts, and that's it. It's just simple np install Open Zeppelin contracts. Oops, it's right here. And I think this boilerplate already have Open Zeppelin. Okay, I will install with yarn add Open Zeppelin contracts. That's it. There we go. And I'm gonna check if it's in my remapping. Remapping is just how you're gonna use like the libraries you are trying to import into your smart contract. So I will say that Open Zeppelin. How is it? Open Zeppelin contracts equals to node models. You should not do that. Just I'm gonna push to main and to this branch just to let you focus on these smart contracts. And that's it. So if we review our node models directory, we're gonna find the Open Zeppelin library installed into our project, and we're gonna find like another directory that says contracts, and we're gonna find all the contracts they provide us and that we can use. So let's check each contract. So we have a utils directory where we can find a lot and a bunch of smart contracts, but we are interested only in the token smart contract that for is the ERC20. So as you can see, this defined as abstract contract. That means that will not compile itself like this kind of smart contract. You're just going to use like the all the functions and events provided by this smart contract for our smart contract. So there is a lot of documentation here. We don't care much. So how you import that? I'm gonna say that I'm gonna import ERC20 from Open Zeppelin. This is the path of the Open Zeppelin contracts. But let me check. Is right here, not models, Open, yeah, contracts. and then we access. Once we are in this path, we define it right here, and then we want to access to token directory. So I will write token, and then I'm gonna write like ERC20. That is the file I want to access. That's it. We already import that the ERC20, and also I will define it right here that my contract is an ERC20. Okay. So, but what happens with this kind of smart contracts provided by OpenZeppelin? So all the time they have a constructor. A constructor is like a function that is executed once you deploy the smart contract. As you can see, this constructor says that you need to write two parameters. The first one is a string, that means like it's a text, and the second one is the same. The first one say that you will write the name, and also you will write the symbol. We can make like this kind of you can write like right here into the constructor's parameter, or you can define it once you include the ERC20. So I will do the second option, and I will put the first name is the name, so I will say RF token, and the second one the RF. That's it. We are using the ERC20 library. So you can do the same with the other contracts provided by OpenZeppelin. I suggest you just to study all the smart contracts provided by them. And also I recommend to use the current version, that is the 5 version. Let's explore a little bit of the library. So also has an interesting feature that I showed you into the home once we get into OpenZeppelin. So I will go to OpenZeppelin wizard. So this OpenZeppelin wizard is like a that can make for you that smart contracts without AI. It's only that you can choose some features here. That means functions, and that's it. That's how you can access and you can get your smart contract. So basic. So we can choose like
advice is use battle-tested best practice templates, which are provided by a well-known agency, in this case, OpenZeppelin.
Yeah, exactly. And in this case, we are talking about only public smart contracts, but all the time you should do that. So if we go to Wizard, we can also, as you can see, it's the same thing we do or we did in the smart contract. We made the constructor, and that's it. So we can also, I'm gonna choose all the features we have. Here we're gonna get some good practices that you should always do. That is the post into your smart contract. That means you can post your any feature, any functionality, or all your smart contract, or all your token, or your NFT, or only post the mint function, or whatever you want to do. You should also add the post function. Even it depends. It's up to you. And it's up the product design that you want to make with your project, or with your app, or with any kind of project you're doing. And also we can make it, we can use ERC20 bots that is for DAOs, but we are not interested with that. And also we can make it access control. We're gonna go deep later with this one. Okay, but also we can make we can add the bots and whatever. And also if I want to change my name and change the symbol and make a pre-mint of tokens, we can do that right here. Also with the ERC20, blah, 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 with the other smart contracts, and that's it. If we copy, for example, I want to copy the, I don't know, maybe a real world asset, that if you can see and you pay attention here, this real world asset is inheriting from ERC20 smart contract. Sometimes a real world asset is not always ERC20, it's usually also ERC721, 1155, and other standards you can find in the AIP documentation of Ethereum. So I will copy this smart contract, and we can paste it, and also we can start to using this smart contract. If I want to deploy this smart contract just to check that works fine, I will say that I want to build all my project, but says okay, this is here we go. So our boilerplate is only config for to detect the Solidity, any Solidity version, but here we has like another version we are not interesting. So I will just say that we're gonna change to the Kodi version compiler, and also, and that's it. We're gonna build it.
But my question is that in this case, if the token contracts you just took as example from OpenZeppelin, if they are templates,
Yeah.
why wouldn't they run under the other compiler, or don't you have that compiler set up, that version?
Okay. Cool. So
Because
here's
they're
the
not
thing.
like they're not specifically private like Kodi, right? There's no need to go through a specific version. Is what I would expect.
Yeah. Yeah. Exactly. If we go, for example, if we go to the compiler version of those smart contracts of OpenZeppelin, let's figure it out who what version has. They have like for example, they have this one, right? And they always gonna use this version. So, but yeah, you're right. If we try to use this smart contract to our smart contract that we're gonna deploy to Core blockchain, will fail. Why? Because obviously these smart contracts are provided by this version, and we are Core blockchain only accepts um, 0819. So yeah, you're right. So what you can do right here, so you can install the OpenZeppelin version for the fourth version. Let's try, and let's try to install this one. I think, if I don't remember, is something like yarn version contracts. Oh, I don't remember. Let me search that. OpenZeppelin version 4 install. Oh, there we go.
Is there in general a risk that you open up to potentially older potential vulnerabilities by using an earlier version? In this case,
Exactly. Yes.
Yeah.
Yes. All the time. We're gonna find an example right here. For example, we have a contract. Okay, so let me cancel the compiling here. We have a contract, for example, that is the second one. Let's go to this. This version is the even not only the Solidity, even not only with OpenZeppelin libraries, also with the compiler of this of Solidity. All right. So for example, in this case, it's only for this version is 076. This is an older version into Solidity, and that version of Solidity has a vulnerability that is the overflow vulnerability. So what that means? So actually, this contract demonstrates, if we can read, interior overflow and underflow vulnerabilities, and is available before or older version before 080, or if you are not using SafeMod library from OpenZeppelin, also you will have this problem. So let's explore it. For example, he says that in addition with overflow protection, you can overflow when you add A plus B. You can exceed this size of variable. Okay, so if we plus without using SafeMod library and this older version will overflow. What that means with overflow, like you will not get the result or the output you are expecting. Um, just will overflow, and literally will get you a random number that was usual, was common like in 2019, if I remember, or 2018, that has this version, or 2020, with the DeFi, with the DeFi, a lot of with DeFi projects, they were trying to vulnerable some smart contracts. Let me show you smart contract overflow showcase or
So we're getting a
examples.
history lesson.
Yeah, because for example, some users or some communities, some projects made their own ERC20 smart contracts without using SafeMath and with the O7 version, and literally a hacker called to a mint function, and once he wants to mint function, for example, they accept a parameter to that is an amount, and they make an overflow because into the function. Let's say I will create another one. Oh, better, I will show you a real showcase. Let me go to this article, and it's very interesting. Let's confirm the date. Yeah, 2017. Look at this. I want to show you.
That's a famous one.
Yeah, that's
Yeah.
that's actually a lot of time. But what projects? Oh, okay, I will ask to whatever you can find it in Google, or if you ask to Perplexity or any other AI, you will find it. Let me ask you, Claude. What project was attacked by overflow vulnerability in Solidity? Is searching the web. All right. There should be a project. Look at this beauty chain. So I will say beauty chain smart contract. That's it. We find this real case. So as you can see, you can exploit literally your smart contract. Let me place this one. That's it. That's how it looks. And once you try to overflow an smart contract, that you can withdraw a lot of funds, so you can mint a bunch and a lot of tokens of that smart contract. So also we find here an example about how to use the SafeMath library, and is very good and very well documented by all the auditors. So I just recommend you just to use a version over obviously over 08 of Solidity compiler. So that's how interior overflow is vulnerability appears. And but you should not worry about it, because I only recommend just to use this version. All right. So okay, let's go with the third one, that is accessible, or the access control. So for example, I will in this smart contract, let me do a basic smart contract for my real world, no, for my stablecoin, let's say, that is mintable, and that's it. Okay, it's probably default, but anyway, I just gonna write again my smart contract, and I will say pragma solidity dispersion. I will say stablecoin, and we can make a function to deposit, and I will say public, and that's it. First of all, I need to explain you what means public, private, view, and this kind of functions. So if we make, I will let me add another example. I will make deposit here C20, and I will say private, and I will say the deposit NFT, public view, and also I will add a function deposit or something like get balance, public pure. All right, first of all, I need to explain you about this because this depends how you can access to the function. So public, as I said, means that anyone, literally anyone, a contract or a user can access to this function. In the case of oh, I forget the internal. Sorry, I forget the function. There was a function get balance. ERC20 internal, external function withdraw. ERC20. So the public, as I said, is the contract and user can access to this function, and also with an internal, only smart contracts, or I would say only smart contracts can call this function, but inheriting. What does that mean? So if I create another smart contract right here, I will create a scalar.sol, and I will copy all this, and I will call it a scalar. And I'm trying to import the stablecoin contract from my RAF token. That's all. I can access to the function internal. Okay, so if I call, for example, function call function, I will say that we can access to stablecoin dot get ERC20, and there we go. We can also put the parameters and all of that. So the thing here is that all these smart contracts can call this function. That means that any other user cannot do that. So I recommend only this for arithmetic or any kind of logic that you want to write into your smart contract. So in the case of the external, only
So the
users. Sorry, yeah,
Yeah.
go ahead.
Now I was wondering, so you're only allowing smart contracts to interact because they will have standardized output? Is that the reason?
Yeah, exactly. Because for example, you can add like an arithmetic or conditional or any other logic right here, and you will retrieve into this function, and you can add some other logic right here, whatever. So yeah, that's the reason you can also add this function.
To prevent human error and human malice.
Yeah, indeed. With any
Okay.
other hacker that wants to use smart contract. In the case of external, only users can call this function, not smart contracts, not other caller. So this usually is a good practice to make interfaces with external. Why? Because if we want to make an interface for this contract, that means an interface means that we'll define for you and we'll define the structure of your contract for functions, events, and errors. So all the time when you try to create an interface, you should make all the functions external. External means that only users can call this function, and you can avoid. And also, it's important to say this, but avoid calls from smart contracts. Okay, and private means that not contracts, not external, not callers to this function. Okay, so this is the scope of all the functions, and you should understand this first before you start using OpenZeppelin. Also, let's start with the public view function. So this means that won't execute any logic, is only a read-only function. So you can also retrieve, like, you will not execute this function means that you will not pay gas for this function. You will only receive a variable. For example, I will say that I want to return hello there. And that's it. That's how it works, this function. And also with the pure means that won't return an output. That means if we say something like return hi, it won't appear and we won't returns anything, this function, because it's pure. So pure means that won't make a logic, yes, but won't return for you, and you won't see this in your Explorer or in your Remix or in anywhere. So we already understand these kind of functions. We can understand the access control vulnerability. So with the thing with access control is that basically that means that anyone can access to your function that can withdraw your funds, but let's say that function is only available for the owner or for a DAO or for a multi-signature wallet or for a third party, whatever, but has not understand access control. So let's read this smart contract. So we have a mapping where we define how many tokens has a user, and we define that mapping as balances. We have the supply, etc., etc. Okay, let's go with this function. So this function, you can withdraw all their funds to a specific address. That means, hey, the contract balance of this smart contract, you will define it as contract balance. Okay, so you will send to the caller of this function, that, remember, message sender means the user wallet. So the user wallet will receive all the funds from this contract without any filter. All right, and that's it. That's how it looks. So if I call this function, and let's say that this smart contract has like 1,000,000 Kari cryptocurrencies, anyone can call this function and go will withdraw your function, all your funds from this smart contract, and that's it. So how you can avoid this? So you should do like a modifier, call it as only owner, means that only owner will is the all it, I mean, is the address of the owner that only can receive and call, and also can call the function. So we can now make like the modifier for only owner, but OpenZeppelin already solved this for us. So if we go to the packages and we go to access and we go to vulnerable, there we go. This smart contract is actually doing for us the is solving our vulnerability. So how you can integrate this into our smart contract? So I will say import ownable from OpenZeppelin contracts access ownable.sol, and I will say there is ownable, and that's it. Let's see if needs if has a constructor. Yes, it has an initial owner. What does it mean is that the initial owner is basically like literally the first owner of their contract. So you should write your constructor. You can put the address. I recommend to put the address as a parameter, because it's a bad practice if you put public variables into your smart contract. Also, because anyone can see that. Also, if you put as a constructor, but it's a better practice if you put into the constructor. So I will say my wallet, I will call it as my address, and then I will inherit my ownable, and I will put right here my wallet address. And that's it. That's how you use the ownable function. And also you can avoid this access control. But access control is more sophisticated than only ownable contract. So if we go to the documentation of OpenZeppelin and we go to access control, we'll find more libraries than this one. So we can find sorry, I don't see that. So we can also use let's see directly from the library. We can see an access and also has an access control right here that looks like the ownable, but here you can assign some roles for any other wallets that you want to manage to your ERC20 or to your multi-signature wallet or whatever. So let's check if we go to Wizard. I will try to use the roles. So there we go.
But does that only apply if you actually have those roles defined? As in, could you just have the top one?
Could be. Yeah, but like you can define before you deploy or once you deploy or after you deploy the smart contract. So, okay, I will explain better right here. I will take this example and I will replace it. I will change the compiler. And okay, my stablecoin says that has a minter role, and as you can see, is defined as byte 32. But also I can add, for example, I will add Robert as my admin role. I will call Robert. I will. Yeah, you will be the admin of this contract. Okay, so we can define this right here, and we can assign to this address. I will say Robert wallet, and I will grant you the role right here into the constructor. Okay, so I will just put right here the wallet I want to assign. And as you can see, first of all, I'm assigning to this constant admin role, and is a mapping between the byte 32 hexadecimal with this address. So if we say that only Robert can withdraw the funds, it will say that he can choose to whatever he wants to withdraw, any amount he wants. And I will say that it's external with the only role that admin role Robert. So only Robert can access to this function. And if you're trying and this is not your wallet, you will this function will fail, right? Because of this modifier. And that's it. That's how access control works. Has also, if we explore, we can also see a more sophisticated smart contract right here, because it has an access manager that is a huge and good architecture of these smart contracts that you can inherit. And but this is, I recommend only for huge projects. These usually use the multi-signature wallet projects like Safe Wallet, but they has their own smart contracts. But usually DAOs use these extensions and these smart contracts. All right. So that's how it looks access control. That's it. Let's go with the other one. This is the storage vulnerable. This is the commentary here, but this is a larger smart contract. Okay, so I will go to another easy smart contract. I will go, for example, a transaction origin. So transaction origin, right, means literally if we go, or you can figure it out into the documentation Solidity, but it's not at all a transaction origin. Is that you are assigning a grant variable as owner when this should be only the message sender. So I will explain also message sender, message value, message the other object. But in this case, as we can see, as we saw, exists a modifier for, I will call it as only owner with the minus, only owner. I will duplicate that one, but this is wrong absolutely because only a wallet can be an owner. So if an owner is a transaction origin, that means that if we use this modifier into any other function, it will fail because no one owns a hash of a transaction. So obviously it will fail because it's not a wallet. Okay, so I will say that it's not an owner. So this is how it should be. And this is grant absolutely because it's not only the transaction origin. You can write like an hexadecimal like address, let's say like an address 0, or actually you can call it as 0 the ETH. This is usually, and this works in any EVM chain. That means like is the dead wallet is the 0 address, because in any other blockchain, even in Ethereum virtual machine blockchains, has an 0 address that no one can access it. All right. So if we say that an address, the 0 address is the owner, literally no one can access to this function. So if you had a bad practices, just to write bad functions, a bad, really, really, really bad smart contracts, you will write and you will do something like that. But I hope you do not do that. So yeah, Robert or Calvin, someone wanted to say something.
Is the so a dead address is so the burn address which nobody could access. Was it?
Indeed.
Help me again. Was it because the odds that someone would manually generate it but randomly are so low that it's regarded dead, or is it because it's an impossible combination with only the zeros after the 0x?
Okay.
That's actually a very good question. That's
yeah, it's a good question. Do you mean like why is like 0x dead? Or
what I'm asking is a burn address which is considered dead to just if you send some ETH to that. Is it because the mathematical the odds that someone would generate that address so would get to know the actual keys is so low that people regard it dead, or is it because it's an actual impossible address to obtain?
Actually, both. So literally, no one can access to the 0 address. The 0 address, I will say it. There are, if I remember, there are two, and I will agree for you. 0x and 16 zeros, and 0x with zeros and at the final with dead. So literally, no one can access to those addresses because are assigned as initial addresses into the genesis, into the blockchain. So I will look for you 0 address dead, and if we go to the scanner, we will find it, and also 0 address only in Ethereum. That is not dead. So we have two.
Already exist, right?
Exactly, already exists,
accessible.
And it's not accessible. Exactly. So here is the interesting thing, and this is like a creepypasta story that you have like 2 addresses, like dead and 0. As you can see into the Explorer, everyone burns their tokens or their NFT. For example, this dude sent like a $0.01 and everything. So yeah, this is the burnable address. Yeah. Okay,
It's like
let's
it's like a
go.
trash can.
Yeah, exactly. Yeah. Um, let's go to, for example, we have 15 examples right here, but let's choose an interesting one. Unprotected. Okay, this is cool. It's the same thing than access control inherit contract that everyone can call this function. Okay. Okay, so we have enough with OpenSimpling for public contracts. Let's go with something more interesting that is for private smart contracts. So Cody already has a library for private smart contracts, and you can find it in their library. So I will go to Cody Smart Contracts GitHub, and if we go to their GitHub, Cody's GitHub, we will find literally this is the library. We can access to, for example, they have a library is only for private. As you can see, this is a private ERC20. And let's explore it. So basically, is actually, as you can see, as a good practice, is using OpenSimpling context. And also, they define their own interface. Is using MPC core. So let's go deep here, because MPC core is a huge library that Cody used to define the private types and private structs and ciphertext too. So this is a huge. If you want to study like literally 8,000 lines of code, go ahead. But also you can you can use an AI just to study this smart contract. Okay, but
Summarize.
the thing here, sorry.
Summarize this 8,000 lines of code for me.
Yeah, it's a lot.
I think that would be a separate stream just on multi-party computing and how it arithmetically works and functions. And I get, for the sake of this tree, I would say that, okay, this is already constructed and we can use it for this certain goal.
Yeah, but as you can see, like a really hard logic, and but it has a documentation. Okay, and I have some examples for you that explains arithmetical, conditional, basic logic, and all the data types. So we go step by step.
Also,
But,
I think Davi has also created a previous stream about this because he set up a server for people who want to use it in their projects. In part of
indeed.
one of our previous streams for the viewer.
Yeah, if anyone is interested, you can look for us MCP Cody smart contracts, and you will find it. So you can it's the same thing like with OpenSimpling Wizard, okay, but with private smart contracts with AI. So basically, it's the same thing. They have a good practices only for private data types, and that's it. But I will show you some examples. Well, this is the flow that I made for MPC Core. That is the library, or how to use the garbage circuits. So there, here we have the user, and the user needs to generate an AES key. AES key is like your little password that Cody blockchain or the literally garbage circuits gives for you, and you can use it for encrypt or decrypt any variable, or to execute a private function or whatever to do with private stuff. So this is the flow. So it generates an AES key, and you encrypt your data, and you attach the encrypted data to a transaction, okay, into the smart contract. Okay, once is the data encrypted, is stored as on chain, or you can also save it into off chain side. and that's how it works. A receiver, for example, a receiver, let's say like Calvin will receive like 10 ETH from me, or I don't know, a million Cori because it's a private blockchain. And
Thank you very
if
much.
he,
Sure.
yeah, a lot of, he's rich. I don't know, Calvin is rich.
Oh, wait, now we're
And
talking. Let me,
Calvin,
let me just.
When
indeed,
is this happening? Good.
I hope so. So, but I do not want to say to Calvin that I have a million of Cori. Why? Because it's his secret. This is my secret, and I don't want to share it to anyone. So I will retrieve and encrypt the data of that million Cori to Calvin, and Calvin only will see a random number. We explain a lot of time in the last live streams, but I want to show you those just a little bit of this flow. If Calvin wants to check my real balance, he needs to access to my AES key. Think that is not possible because I will not share it, and it's my little password to use for across my smart contract. So this is impossible to access it, even if he has the access to my key. Right. So this is a little bit the flow. How I explain how the ES key is using the smart contract and the third party. And that's it. I also explain a little bit the key features, privacy first, EVM, etc. This is also in docs.cari.io. But I want to show you something more advanced that is more for private smart contracts. So obviously you need to understand the basic smart contract vulnerabilities and good practices before you come to create a private smart contract. But don't worry, I have some examples for you. This is some I add and attach 10 vulnerabilities available in that you can make with bad practices into your smart contract. I explain very well withdraws. I won't get in touch here because it's harder to explain, and we can take a lot of time to explain it. But later we can talk in another live stream about these scenarios and these vulnerabilities that appears on that you can see in private smart contracts. But the thing I want to show you is the best practices. So as I said, use the latest Solidity version. I recommend in Cardi blockchain to use this latest version that is, as I said a lot of time, 8.19. Avoid old versions. All right, this is the first recommendation I have for you. Specify the license. So there is a lot of license that we can go to right here. We will retrieve any kind of licenses that Solidity that you can write in Solidity, so you can make a private or you can make a for public or whatever. So specific imports. So why this is so important? Because if we go to, for example, we have MCP card that I think I have it here. Contracts, utils, MCP core, MPC core. So I can access literally to an struct or only to this library or only to this struct or to this one or to this one or to any other one. So if we, for example, as you can see, I always try to import the specific library or specific variable and struct from the library. So that's a good practice. Security patterns, check effects interaction patterns. Obviously check the validations. We have two kind of validations. Okay, I will use this example. So we have the requirement and the if else. So let's say that I want to withdraw my Cody. That is only for external access, and I want to return an and an address. And we have the first one is, I will say, requirement. that looks like this. I will require into this function logic that the message.sender is equal to the ownable or to the owner. Okay. If not, I will say this is not the owner. Okay, I forget. We have also a modifier that is a third one. That is the same thing that I showed you that you can add it as only owner. That could be a modifier or also could be a requirement. So in this case, I want to make as a requirement. So require that message sender should be the owner. If not, it's not an owner. Also, we have another requirement. Well, this is the if else. Let's say if message sender is not the same as the owner, please revert. And we can define right here an error into this contract that I will say invalid owner. And I want to show into this, well, only this invalid owner, and we'll revert with this error. And there we go. If or actually else, go ahead with the logic. Okay, cool. So this is basically the requirement and the if else. I recommend if you are in an expensive chain, I recommend highly this because we don't talk about the gas prices in Cody because Cody is really cheap, so we don't care about that. But for example, for builders that create projects, create smart contracts in Ethereum, they should care about the gas good practices. So these are gas good practices. Let's go with red transit protection. That is the first vulnerability we talk about. Also, OpenZeppelin has this library and the access control, as I explained about the roles. Okay, then I use the transaction origin. Also, okay, let's go with possibility. This is a good one because if you import a poseable smart contract, you can pose any other function or functionality into the smart contract or whatever you want to pose, and on pause also. You can also, for example, this is a type of a transaction. We have three types of transfer. Okay, to transfer cryptocurrencies. This is the first one. This is the best to use it. Even Solidity engineering team recommend you to use this kind of function that is the same kind of transaction I show you, that you can call and you can select an amount to transfer. Also, we have this other transaction that means that to this address, please transfer the amount you are writing. Okay, that's the thing, and you should always avoid this kind of transaction. Okay, you should not do this kind of transaction. Obviously, into OpenZeppelin appears with the ERC20 contract, but also you have the safe ERC20 contract. You can explore more about it into this documentation. Okay, this is a good one, validate address, because probably you do not want to let withdraw your NFTs or your tokens or your real world assets. You don't want to any user send or burn their tokens because can affect your total supply or your whatever. So you can do that with this requirement that any user cannot send to the dead or to the zero address, or even to the contract itself. That means this is the address of the smart contract, so you can avoid also. Obviously, external calls, I already showed you. Gas limits, we do not care in Cody because it's cheap. Delegate call. So, okay, so you can allow any functions and libraries or contracts into your smart contract. So you can define what kind of function is allowed to interact or is allowed to call, even for internal or external calls. And this is
Can you
a
give an
good
example?
practice. Yeah, of course. So let's go here, and I will say, I will copy this one. Okay. This is a little bit hard to explain, but the bytes for that is an hexadecimal is like the ID. Okay. So, for example, if into this smart contract, okay, let's say the Open Zeppelin contract, I will say ERC20. For example, this function name has an hexadecimal, let's say translate or identifier that could be something like this. Okay, so all the functions has an hexadecimal, so you can assign or you can access to that hexadecimal with a mapping. In this case, we can access to, okay, I'm gonna write a function, the allow function, and I will accept a bytes for, then I will call it function name or function x, and this will be external, and this will be only, well, whatever. And I can change the, if we have this mapping, that means that, for example, the hexadecimal 0x 123 is true, is assigned to the true boolean. That is the name function. If we want to access to the B, that is the, for example, symbol name, and is false, is assigned to the mapping false, we'll say that this function, this function is not accessible into this smart contract. So we can literally just delegate call to that function. And I do not see that honestly in many smart contracts, this kind of practice, but it's usually into off-chain accessible. For example, private smart contracts, and actually Cody Ethers has this kind of functionality to access an hexadecimal contract. So literally is like this example. If we, for example, the other functions you can assign as true or false, that means true, you can access to the function. Is false, you cannot access to the function. So also you can validate data. As I said, you can validate the address of the color, or you can validate the amount of the parameter, the block timestamp. This means that is the timestamp of the block at this time that is running into the blockchain. We can also validate array length.
Wait, we'll go back one step.
Yep.
We know that blockchains, they count in blocks because they don't have a concept of time in seconds and hours, etc.
Okay.
So in this case, it just checks if a certain block is passed, and if so, then it'll stop performing the function. That's the idea.
Yeah, well, the idea with block timestamp is that you can assign, for example, I want a bet auction smart contract. Okay, so I can create like literally a function. I will make an example right here that you can activate the bet. So you can choose. Yeah, so you can select like use block timestamp for any other schedule.
And then at that point, it closes the opportunity to place a bet in the smart contract.
Yeah, exactly. And also I recommend you just to let you read all this page. So I will go to the auditors and how you can audit your smart contract if you have a big project and you have a huge ecosystem or whatever. I recommend, for example, we have Hacken. Oh, that I have this one. In Hacken, you can see public reports of their audits into big projects. Okay, so I will go to, for example, into audits, and I can access to any audit they made for any project. For example, we have Bybit, we have CoinDepot, OKX. For example, I'm interested in OKX. Is deployed in Ethereum. Oh, but okay, now this is made in Rust. This is not smart contract. We are interested in smart contract. So I will go to Bybit. Okay. In Bybit, they made some audits and some reports, and we can see the report right here. That all this is public, so you can start to study the vulnerabilities they found into their smart contracts. Also has their analysis, has the performance of the smart contracts. Everything should be public. Let's find some private that has their smart contract outdated.
Yeah, because the proof of reserves are more of a literally that proof of reserves, less of a security audit.
Exactly.
Yeah.
It's not a smart contract itself, but yeah, you're right. Oh, okay. For example, this is a ERC20, and we have a besting. For example, I want to access to this one, and okay, there's a little bit on overview. This is in Solidity. This is an ERC20 token, and I want to see the report. And you can also see the report right here. There's a repository of that project, has defined some the severity of or critical vulnerabilities. If it's critical, high, medium, or low. Those are the categories. And also you can study.
Do they link to document? May I ask? Do they link to documentation?
Yeah, of course.
The one you just showed.
I will. Okay, I will. I already showed.
No.
What did you talk about?
No, I mean in the report. If you see the, for instance, the severity chart, do they provide a reason what the vulnerability entails? As in, do they have a indication?
Yeah,
for as inspiration for developers.
Yeah, I should just to check into the report if they are taking care about like
they do. So yeah, I just noticed they do.
Yeah, exactly.
Awesome.
So as you can see, they define like in this category like an if conditional or something like that or whatever. So in Hackett, you can check like some audits and some good practices also for Solidity smart contract. And also we can find, for example, if you're a senior smart contract developer, you can also access to Code Arena and you can start to audit in public smart contracts for the projects they are dropping here. And that's it. That's how you can start to auditing. Also, even you can look for in Twitter or whatever to other project or auditors for your smart contract. But for private smart contract in Cody, we are working with that. But also you can see if for your public smart contract, you can access to those tools. Also, I think that if you know Consensus is like that company that own MetaMask and all of that. Consensus has also an audit, called it as diligence. So diligence also audits some Ethereum smart contracts. All of that should be public because obviously in Web3 should be public. Even if you don't want to use like public your funds, but secure, obviously, Cardi blockchain is the answer for that. But I mean public in terms of when you have vulnerabilities into your smart contract or who hacked literally your smart contract or who stole your funds or whatever. So that's why all the auditors should have and also have public documentation or reports about their audits of that smart contract. So that's how we have this live stream. If you have any question, please drop into this chat. And also I shared with to you like this wiki will work for you a lot. Is literally a draw version of the docs.io in terms of example of smart contract when you try to use Garbal Circus and MCP Core. I don't know if you have anything to say, Colvin, Keen, Robert.
I would have a recommendation. There's a lot of vectors that come into play when you're developing in public. So when you're developing smart contracts, which are decentralized, which means there's a lot of more things to take into account versus running something on a single system. If security is something you're interested in, in the past I worked at a cybersecurity agency for a while. And due to interest, I joined several communities also on Discord, which are quite supportive if you're making your first steps. You already mentioned Code Arena. They have a great Discord community. There's a few I'd like to mention. There's a few. OpenSense is worth checking out. Olympics, ImmuneFi, Guardian, and Quill Audits. DeFi, Hack Labs, and HATS are the ones I would recommend. I joined in the past as Discord communities.
Yeah.
And of course, from my side, I would always recommend to check out our next streams as well. But I'll close with those.
Yeah, indeed, Tim. So that's it. Of course, we're gonna go deep in other live stream about advanced vulnerabilities in private smart contract because they are more complex. Obviously, because of private structs and private behavior of smart contract with garbled circuits, and also with interaction once you onboard or offboard your ciphertext when you try to put an encryption or you want to decrypt something. So yeah, also I recommend all of this. If you want to start to study, go ahead. You're free to do that, obviously, and you can start to experiment this. So I recommend to use this boilerplate also because has the configuration with Kodi. So also has some commands to deploy smart contracts. For example, I want to deploy this smart contract. You can just need to literally write yarn the smart contract. Obviously, I have like this contract, so I just will try to delete it. And also you have like an examples for testing. Like this is a test of MPC arithmetic contract. That's it. I recommend this boilerplate just to let you use if you want to start to using with Kiro or with Cursor. That's it. Thank you so much for this live stream. We have another live stream, as Robert said in the beginning of this live stream. So thank you